In this section, the first thing we're going to talk about is something called a max and a min, axis of symmetry, and a vertex. Specifically for a graph that looks like this. Two options, like a U shape going upwards, and then we can also have, just a U shape going downwards. So both of these are, examples of ax squared plus bx plus c. Okay, so both, with the x squared, we have a parabola. So both of these are examples of this, just different a, b's, and c's. One thing to note, this one right here has the a term being positive, and then the b and c are unimportant, and this one right here has the a term being negative. And again, this b and c doesn't matter. As long as this a term is positive, it's going to move upwards. As long as this a term is negative, it's going to move downwards. Like we said, so we're going to talk about three things: either a max or a min, the axis of symmetry, and then the vertex. All right, so this point right here, this is called the vertex. And so, the vertex has an x value, call this just x, and it has a y value. So this x value right here is the axis of symmetry. Axis of symmetry. And this y value in this situation is going to be a minimum. It's a minimum because this is the smallest value and it keeps moving upward. Over here, we have the same thing. So here's like your x value and here's your y value. Here again, this x value is the axis of symmetry. And this vertex, we have the point xy. This number right here, that's the axis of symmetry. And this number right here in this situation is going to be a maximum. It's a maximum because this is the biggest point. So that's just basically what the picture, what these three things mean. And then we're going to have equations for them. So the max or the min, it's always going to be this number, f of negative b divided by 2a. So, here's our a, b, and our c. We have to find what is negative b over 2a. That's just a number. Maybe it's 2. And then we plug that number into our equation, and that's going to be the max or the min. It's either going to be only one or the other. So like we see from this picture up here, a bigger than 0, this implies that a less than 0, this means that we're going to have a max. A is bigger than 0, this means that we're going to have a min. So we're only going to have one or the other. It depends on this, this a right here. Okay, the axis of symmetry. It doesn't matter, a, b, c's, whatever, they can be whatever they want. It's always going to be this equation, x equals negative b divided by 2a. So whatever this number is, x equals that, that's the axis of symmetry. And the vertex, that's a combination of both of these two things that we found over here. So the vertex is a point, so we're going to have an x-coordinate and a y-coordinate. The x-coordinate is going to be the axis of symmetry, negative b over 2a. And then the y-coordinate is going to either be the max or the min, f of negative b over 2a. And that's what we described in this picture above. We said this x-axis, the vertex, it's a point. This vertex is a point, x comma y. We said the x part was the axis of symmetry. Here we said the axis of symmetry was this, so we put that right here for the x part. And this point right here, either the min or the max, in this case is a min, that's the y part of the vertex. And we said up here, that's this piece, so we put that piece right here. So this is the equation to find all three of these things. So on the next page, let's just go through a quick example of this. Let's do this for f of x is equal to negative 3x squared plus 6x minus 1. And let's find those three things. Let's find either the max or the min. Let's find the axis of symmetry, and let's find the vertex. Okay, let's start with the max or the min. So on the previous page, we see the max or the min is just this equation, x equals negative b over 2a. Sorry. That's for the axis of symmetry. The max or the min, this was this point, f of negative b over 2a. So we need to find this value. And remember, we said that we're only going to either have one. We're either going to have a maximum or we're going to have a minimum. And that depends on this a value. So since our a value is negative 3, Negative 3 is less than 0. If we look on the previous page, whenever we have an a value that's less than 0, that means we're going to have a maximum. So this value right here, this is going to be a maximum. And it's a maximum because we have this. The a value is less than 0. Okay, so now we need to find this value, f of negative b over 2a. So what that means is first, let's just find negative b over 2a. Negative b over 2a. Okay, so here's our b. It's 6. So we're going to do negative 6 divided by 2 times a. A is minus 3. So that's going to be negative 6 over negative 6, which equals positive 1. So what we need to find is f of positive 1. We're trying to find this value right here, f of negative b over 2a. Negative b over 2a, that's equal to 1, so we've got to find f of 1, and that's going to give us our maximum value. So f of 1, we're going to have minus 3 times 1 squared. Then we're going to have 6 times 1, and minus 1. Okay, so that's just going to be minus 3 plus 6 minus 1, which is equal to 2. So this tells them we have a maximum of 2. All right, so there's the first part of this question. The second part of this question, let's find the axis of symmetry, but we already did the work for that. So if we remember axis of symmetry, so down here, that's just x equals negative b over 2a. It's this equation. We found negative b over 2a. Negative b over 2a was 1. So our axis of symmetry is just x equals 1. So x equals 1 is the axis of symmetry. Okay, and again, now let's find the vertex, but again, we already have that answer. We said in the previous page, the vertex was this. It's a point. It's negative b over 2a, f of negative b over 2a. But we already said negative b over 2a. We found that that was 1, so this is going to be 1 comma f of 1. Again, we already found f of 1. F of 1 was 2, so our vertex is going to be the point 1 comma 2. And then we're done. So we have our three things. We have our maximum in this situation is 2. Our axis of symmetry is 1. And then our vertex is the point 1 comma 2. Okay, so let's move on to the next topic. So this next thing we're going to discuss is called end behavior. So what end behavior means is that we're going to have 4 separate examples. We can have something like the graph eventually moves upwards on both sides like this, and anything can happen in the middle. It can squiggle a bunch, it can just be constant, it can go up, go down. All that matters is eventually the graph's just going to move up on this side and the graph's going to move up on that side. So that's one option. Our next option is the graph is going to move down on both sides. Again, anything can happen in the middle for the graph. The graph can go up, go down, but eventually just as we move left, the graph's going to move down, and as we move right, the graph's also going to move down. Another option that we can have is a mixture. So one side the graph moves up and the other side the graph moves down. And then the last possibility is it's going to move down on this side but move up on this side. And so these graphs, they're all going to be for functions like this. Say an x to the n minus 1, x to the n minus 1, a1x plus a naught. So functions of this form, a number times x to the n, another number times x to the n minus 1, all the way down. So just an example, let's do just down here a couple of quick examples. Something like, x to the 10 plus x to the 8 plus 2, something like that. So here, something like that. Another one, we can do 30x to the 11 minus 30x to the 10 plus 1. So these are all examples of equations of this form. And so there's one specific term in here that's important. That's going to be this first term. So this first term right here, this is called the leading term. And it's just the term that has the biggest exponent. And in this situation, the biggest exponent is n. So this whole thing is called the leading term. This little an piece, let's write that down here. So that leading term, that an x to the n. So this little piece right here, the an, that's the leading coefficient. And so those two names are just kind of important if we say them. And so now these graphs are, the end behavior is all going to be determined by this leading term, by two things. One is if this the leading coefficient, is it positive or negative? And the power, is this an even or an odd number? So for this example right here, we have our leading coefficient, so our an is positive, and we also have this n is an even number. So this is an even number and this is positive. The n behavior is going to be something like this. This one over here, we're going to have our an has to be less than 0, and also our n is going to be even. So an even number like 10 or 16. This one right here is we're going to have our leading coefficient be positive, but the n has to be odd. And then this one right here, we need to have our leading coefficient to be negative, and then the n also to be odd. So depending on the polynomial we're given, this piece up here, depending on the leading term, whether it satisfies either this condition, this condition, this condition, or this one, that's going to be what depicts our n behavior. All right, so let's do quick examples with this. So say if we want to find the n behavior for some of the following. Say, let's do the first one, negative 13 x to the 11 plus x to the 7 minus 10 x to the 5 plus 1. Okay, so we have to look for our leading term. That's the thing with the biggest exponent. Here's the thing with the biggest exponent, an 11. So our whole leading term is this. So this is the thing that's going to depict our n behavior. So first, let's talk about the leading coefficient. So our leading coefficient is minus 13, okay, and that's less than 0. So now if we look back on the previous page, I had all those tables. We have to look for the ones that have the leading coefficient less than 0. But also the power, which was n on the previous page, that equals 11, and this is odd. So if we look on the previous page, whenever we have a negative coefficient and an odd power, the n behavior is going to be this one. It moves up on the left, moves down on the right. So for this example, this is going to be our n behavior. And this is how you would draw your answer, just this graph right here. Let's do another example. How about we can have, so g of x is equal to 100, x to the 100, plus x to the 18, plus x to the 17, plus 2. Okay, so the biggest exponent we see is 100, so here's our leading term. So our leading coefficient, that equals 100, and that's positive. And our leading power, this number, which is 100, so our leading power, which is 100, and that's even. So here we have a positive leading coefficient and an even power. And if you go on the previous page, the table that has that one, that means we're going to go up on the right, and we're also going to go up on the left. So this is going to be our n behavior for this graph. All right, so those are just two quick examples for n behavior. The last thing from this section is going to be, let's just do it with an example. So what we want to do here, say f of x is equal to x plus 2, x minus 10, x plus 8. And what we want to do is graph this. So we're not going to use an xy table here. It's going to be too hard. We have to put too many points on to get like an accurate graph for this. What we're going to do is a similar technique that we've done before, but we're going to be applying it to this problem. So whenever we want to graph equations that look like this, you just have a bunch of pieces over here. The first thing we want to do is factor. In this situation, everything's already factored. So that's good. The next thing we want to do is find the zeros. That just means set this equation equal to 0 and then find those x values. The next thing, we're going to put them onto a number line. Sorry, not numberling, number line. And test points, which we'll see with an example what that means. So first step's already done. This thing's already factored for us. So the next thing to do is find the zero. So let's set the equation equal to 0. Okay, solving this just means x is going to be minus 2, x is going to be 10, x is going to be minus 8. So now let's put this onto a number line. Also, we want to put them onto a graph. Let's do that both at the same time. So here's a graph. Let's put these points on. Here's minus 8, Here is -2, and here 10. And on the graph, no matter what, we're putting closed circles here. Okay, now let's go into a number line. Okay, so here is -8, -2, and then 10. It doesn't really matter here about open or closed circles for this problem, for the number line. Just over here, we're gonna put closed circles. So now we wanna pick some points in between each of these sections. Left of -8, let's choose -10. In between -8 and -2, we could choose -5. Between -2 and 10, we could choose 0. Bigger than 10, let's choose 15. Now what we're going to do is plug these into this formula to see if we're going to get a positive or negative number. The formula, you know, the x plus 2, x minus 10, x plus 8. Okay, let's start with -10. If we're plugging that in, this is going to be a negative number, that's going to be a negative number, and that's going to be a negative number. Multiply 3 negatives, you get a negative, so we're going to put a minus sign here. The next step, so let's do the -5. We would get a negative, and then a positive. That's going to give us a positive. The next one was 0. We would get a positive, a negative, and a positive, which is negative. And then the last one, 15, we would get positive, 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 which is positive. So the whole reason why we just did that is this is going to tell us how to draw our graph. So we look at each of these sections, the -8, the -2, the 10. So to the left of the -8, since if we look on this number line over here, here's -8. To the left of the -8, that's a minus sign. That means the graph's going to move down. You know, minus means you go down. In between -8 and 2, we have a plus sign. Plus sign, we're going to go up. But we have to come back down and touch this next dot. So that's always going to be the case. And if we think about it, the reason why that is well, because when we set our equation equal to 0, we saw the equation has to be 0 at -2, 10, and -8. So the graph has to touch at -8, -2, and 10 because the graph is 0 there. So here's a y value of 0. The graph has to be 0 at these points. But this plus sign says the graph's going to be positive in between these 2 points. So positive means we go up, but we have to come back down to touch this one. In between -2 and 10, we look here, that's a minus sign. Minus sign means it goes down. So in between these 2 points, it has to be minus. But then we're going to come back up and touch the point. To the right of 10 is positive. Positive just means we go up. And so that's going to be the technique of how to graph anything that looks just like this. We'll do these steps right here.